Welcome back, students. Let us now complete section 2.2. We talked about most of the important things about histograms in the previous video. One thing I did not cover is this one, advanced histograms with uneven class interval width. I'm going to bury this topic toward the end of this video so that it does not get in the way. We talked about types of histograms, and I took these pictures from the textbook. First picture is showing symmetric. I don't like the term normal, but symmetric, or also it's unimodal. What do you mean by a mode? It means a peak. And the first histogram, third, fourth, and fifth histograms have one mode, one peak. So those are all unimodal. And if you look at the last one, that's bimodal because there are two peaks. And then the second one is hard to tell. It's kind of uniform, but that kind of thing never really happens. What usually happens is going to be some kind of rectangles going kind of jagged, up and down. So it's hard to tell whether it is uniform or it is actually multimodal, many peaks. First one is definitely symmetric, and the second is definitely symmetric. And third and fourth are interesting. Skew to the right means stretched toward the right, and skew to the left means stretched toward the left, not the other way around. And finally, number 6 is bimodal. There are two modes, there are two peaks. If you have more than two, then you can use the term trimodal or things like that, but usually we call those just multimodal and just walk away. Now the final topic that we have to discuss before going over to advanced histogram will be OGIFs. What is an OGIF? It's a kind of line graph that represents cumulative frequency. And most typically, we superpose OGIFs with existing histogram. Here's an example. The first one is an important example, as a matter of fact. We have the same class intervals, same histograms, and those are given by those blue rectangles down here. And what about the S-shaped curve, or this polygonal curve given by a bunch of line segments? That one's called OGIF. Please note that it is always increasing because we're talking about cumulative frequency. And it is given by kind of like this. Well, here's a frequency table which corresponds to class intervals of 30 to 40, 40 to 50, 50 to 60, and so on, and we have those frequencies. And you can measure the cumulative frequencies. Less than 40, there's one. Less than 50, putting all those together, we have 1 plus 0. And less than 60, putting all these together, we have 1 plus 1, that's 2. And less than 70, putting all these together, we have 6. And less than 80, putting all these together, we have 16, and so on and so forth. And eventually, if we get entire everything, then you have to have the total. If you divide everything by the total, then of course you're going to get decimals and percentages, and you're going to get relative frequency, relative cumulative relative frequency, rather than just cumulative frequency. But they're the same. They're not going to affect the shape of the graph. And that kind of thing is called OGIF. How do you put all those dots there? X-coordinate is the midpoint of the interval. So we put X value as 55, 65, 75, 85, and 95 respectively. And then Y-coordinate will be the cumulative frequency that we got in this table in the third column. That one is called OGIF, and typically OGIF and histogram are pictured together. Histograms, of course, stand alone most of the time, but OGIFs, usually we picture together with histogram. But even if we don't, it's still an OGIF. Let's see. Okay. Let's go ahead with an example. The following table shows the monthly electricity usage of a certain household from June 2013 to June 2014. Produced a histogram and an OGIF. We did an histogram before, and we partly used this bar graph to get class interval given by 250, 500 and 750, 750 to 1000, 1000, 1250, and so on and so forth, and get all the frequencies by counting, or getting relative frequencies by dividing everything by 13, and you can produce histogram like this. How do you produce an OGIF? Instead of just frequencies, we want cumulative frequencies. So for example, less than 1000, frequency is 4 and 1 together. Add them together, we have 5. Less than 1250, then we have to add all these together, and you get 8. Less than 1500, add all these frequencies together, we get 11. All these are going to be y-coordinate values, and x-coordinate values will be the midpoints of the class interval. Don't pay too much attention to this mathematical command. Actually, it's a bit too complicated. I should have erased or hid it. And here's an OGIF, and starting from 0 and all the way up to the total of 13, because there are 13 months. And please note that we have to have an increasing graph. Graph always goes up because we're talking about accumulation, cumulative frequency. Adding up a bunch of positive numbers, we have to have increasing. Okay, so much for OGIF. And let's talk about the final topic that we set aside. Here, advanced histograms, class intervals with uneven width. In this case, instead of height, we have to use area. Area corresponds to frequency of relative frequency. As a matter of fact, we're looking at two candidates of histograms. One is right and one is wrong. The blue one is wrong, actually. We simply use frequency as height of all these rectangles. Consequently, what you see, we have one student in this class interval between 30 and 50, and one student between 50 and 60, and one student between 60 and 65. But all these three have the same height. Looks like they are all equally as important. But no, not really. If we have bigger class interval size, it's more likely that a lot of items will fall there if it is equally as likely. But we still have just one student in this large class interval size versus the same frequency in the small class interval size between 60 to 65 versus between 30 to 50. We can see it's a lot more likely that I'm going to select a student. I'm going to end up with a student if I go with the third interval, 60 to 65. And my histogram must reflect that. And this blue one does not. Now if you go over to the red one, or this pink one, you see the difference. Because we use the area instead of height, and you see that the first rectangle is a lot flatter than the third rectangle. Actually, it's just a quarter of the height. Consequently, the third interval is more important than the first. And the second interval between 50 and 60, and the last interval 90 to 100 are the same because we have the same number of students in the same size of those intervals. And this corresponds to, let's see, this kind of observation, area corresponding to frequency or relative frequency. As a matter of fact, relative frequency is actually a little bit better in this particular case is readily relating itself to calculus, to tell the truth. Because if you use calculus, area computation is related to something called integral and antiderivatives and so on, and you can use all kind of calculus tools and so on and so forth. Okay, I'm getting a little bit too much overhead for 1000 level course, but that was to a certain degree necessary because the kind of students who are still listening to my recorded lecture about this advanced histogram must be the kind of student who are interested in going further into higher level statistics like Math 3680 applied statistics or higher, which is required course for math teachers who would be teaching this course or equivalent courses in high school. In that case, more advanced analysis, more advanced knowledge is necessary, and starting point is this observation: area corresponds to relative frequency. Okay, that's it for section 2.2. In the next video, we are going to talk about the second half of chapter 2, numerical descriptions.